going to discuss about in this video, I'm going to discuss about the relationship between heat capacity at constant pressure and heat capacity at constant volume for a perfect gas or ideal gas. So in this, for understanding of this CP and CV relationship for a perfect gas, so we need to discuss two things here. One is uh, internal energy internal energy change internal energy change of a system internal energy change of a system with the variation of temperature variation of temperature. As you know that internal energy change delta U is the state function. Delta U is the state function. So function with temperature and volume. Where temperature and volume are the state functions, state variables. So internal energy change also depends upon the temperature and volume change. So that means the change in the internal energy is the function of temperature and function of volume, we say. That means if you plot the graph between internal energy and temperature, where internal energy U is taken on this z-axis, and on the x-axis if you take the temperature and for increasing of the temperature, so there is increasing of the U also taking place. The graph will be like this, so we can get the curve. So increasing of the internal energy, so like this curve will get, and so at the constant volume, so V is taken as, so V is taken in this direction y-axis. So V is kept constant. V is taken as constant. Volume change is a constant. And rise in the temperature. When temperature increases, there is increasing of the internal energy. So here internal energy change delta U is taken on this. So and show the curve, increasing the curve with respect to the temperature. Hence internal energy change is a function of the temperature, we can say. And at particular point, A point or B point, if you take, and if you draw the one tangent line, so this tangent line, so at the constant volume, which is said to be, which is equal to, slope is equal to CV. So where CV is nothing but change in internal energy upon change in temperature. So at constant volume, so change in internal energy of the system is so functional to the temperature at the constant volume. So that is said to be heat capacity CV. So CV, so which is equal to Q upon delta T, or we can write Q at constant volume is equal to CV into delta T. Delta T is equal to how much? T2 minus T1. T2 minus T1 we say. So where the heat transfer to the system heat transfer to the system at the constant to volume will be so equivalent to, can we write the equation QV is equal to CV into delta V, which is equivalent to change in the internal energy. Change in the internal energy. So this is the equation which is that means internal energy change is equal to heat transfer to the system at the constant volume, right? And another another term is so enthalpy change. So here is enthalpy change with the enthalpy change with the change in temperature, change in temperature. So as you know that enthalpy change also the state function. It is also function of enthalpy change. Delta H is it is a function of what we say temperature and also the pressure. Enthalpy change is the function of temperature and pressure we say. So enthalpy change with the change of in the temperature. That means, so what I mean to say, delta H change in the enthalpy is a function of temperature and pressure, because temperature and pressure also the state variables we can say. Now, if you take so enthalpy H, enthalpy change on z-axis if you take, and on the x-axis if you take with the temperature, and with the pressure is taken on so y-axis, so which is taken as constant if you consider so if with increasing temperature there is so change in the enthalpy also, it can be the graph will be, we can get the curve. So as we have seen like internal energy change. So at any particular point, if you plot or if you write that, so what is that tangent line? If you plot, if you draw, so that slope of this line, so with equal to Cp, we can get so heat capacity at the constant. So this line is said to be slope is nothing but heat. So heat capacity. So at constant pressure we can write, So at the constant pressure, enthalpy change is a function of the temperature we can say. And if you plot the graph between, plot the graph enthalpy change. So enthalpy change. So with the temperature, if you plot the graph, we can get the curve. So that curve, and for this curve at A point or B point, if you just write the tangent line, so tangent line, that means slope, that slope which is equal to heat capacity at the constant pressure. Then so Cp, so at the heat capacity at the constant pressure equal to heat supplied or heat transfer to the system, so and temperature change, so which is equal to enthalpy change. So enthalpy change equal to what we write, delta H we can write. So then it can be written as Q transfer to the system at constant pressure. So then Cp into delta T. So delta T will be so T2 minus T1. So final temperature minus initial temperature. The difference only what we call means delta T. So then it can be written as QP is equal to Cp, heat capacity at the constant pressure, into delta T, so which is equal to delta H. We can write this equation as QP is equal to Cp into delta T is equal to delta H. This is the second equation. The second equation, so we got. So then we got the two equations. One tells that QV is equal to CV into delta T is equal to delta U, internal energy change. There is another equation is QP is equal to CP into delta T, so which is equal to delta H, enthalpy change. So these are the two equations we can get, and that means energy change or internal energy change with increasing of the temperature, and enthalpy change with increasing of temperature at constant pressure at the constant value. As we know that the enthalpy change, delta H is equal to enthalpy definition is change in internal energy plus so uh, product of pressure and volume change. Product of pressure and volume change, so is the definition of enthalpy change. This is the equation. So then we can write internal energy change, so is equal to CV into delta T, plus delta P into V. This is the equation. And then delta H change equal to CP into delta T. We can write this equation. So the Cp into delta T is equal to Cv into delta T plus delta PV can be written as nRT. So delta nRT is a change in temperature. So ideal gas equation PV equal to nRT. So where N is number of moles of the gas, R is universal gas constant, T is the temperature. So we can write PV equal to nRT. So for fixed moles of the ideal gas, so for 1 mole of ideal gas, so for universal gas constant, then temperature, and if you write the equation Cp is equal to Cv, plus nR, we can write R we can write, because N is for fixed mole and constant mole, and R universal gas constant. This is the relationship between heat capacity at constant pressure, heat capacity at the constant volume, Cp equal to Cv plus R. So is the relation we can get from this uh, internal energy change and from the enthalpy change. Thank you.